What's up guys? This is Engineer Jack and this is Structural Theory. So yung pag-usapan natin for this presentation is about the shear and bending moment for beams and frames. So we have two topics. Yung una, the axial force, shear and bending moment, and the shear and moment diagrams. So for example, meron tayong beam, simple beam na pin connected sa isang support. Another support is roller. And meron tayong applied loads na distributed load which is W and concentrated load na naka-incline at angle theta from the horizontal. Siyempre, yung meron tayong reactions, support reactions. So, for pin, meron tayong dalawa. And for roller, isa lang. So, para makuha natin guys yung axial force, shear, and bending moment, we'll use the method of section. So, magka-cut tayo in this structure. For example, nag-cut tayo at along this length. So, for example, this section is tawagin natin CC. So, magkakaroon tayo ng internal stresses dyan. So, ito guys yung itsura ng internal forces or stress resultants natin. So, either of the two terms. So, pwedeng internal forces or stress resultants. Kung kinat natin na member, yung section na yun, so magkakaroon tayong dalawang portion, so left portion and the right portion. Itong shear, axial, and moment, these are the stress resultants na pag nasa left portion tayo, ito yung mga direction ng mga stresses natin. So for example, yung shear natin, pababa, yung axial force is yung direction niya to the right, and yung moment natin is counterclockwise. Pero pag nilipat natin yan sa kabilang portion, which is the right portion, babaliktad lahat ng direction. For example, yung axial force is kung to the right kanina, pagdating dito sa right portion, magiging to the left na yan. Kahit sa moment and sa shear. So, ang purpose na guys, para equilibrium yung stress resultants natin kasi hindi pwedeng magkaroon ng resultant. Dapat equilibrium. So, sa sign convention naman, ito guys yung sinusunod natin, especially dito sa structural theory. So, for sign convention, if we have a section, tapos in-cut natin, ito yung mga sign convention niya. So, pag nasa left portion niya, ito yung passive na internal forces. We have a positive axial force na to the right nga, and pag shear, pababa, and pag moment, pag sa left portion, is counterclockwise. Tapos, pag sa kabila, magiging baliktad. So, ito yung sign convention natin na dapat positive yan. So, pag external forces, so balikan ko lang guys, no? Itong section, pag kinat natin, yung nasa loob, these are internal. Pero pag external forces tayo, ito naman yung positive, axial force. So, basta pag tension or palabas yung direction of force natin for axial, that is positive. Tapos pag shear naman, ito yung positive na this is the external forces, positive shear. So, ito yung direction niya. And for moment naman, ganito. So, pag external, baliktad. So, pag magiging positive sa left portion, pag yung direction niya is clockwise. And for right portion naman, pag external yung moment, positive siya, counter sa right portion. So, ngayon, meron tayong procedure for analysis. So, the procedure for determining internal forces at a specified location on a beam can be summarized as follows. So, at any point the beam of our structure, pwede natin guys makuha yung internal forces, which is the axial force, shear, and moment. So, this is the procedure. So, number 1, compute the support reactions by applying the equations of equilibrium. Number 2, pass a section perpendicular to the centroidal axis of the beam at the point where the internal forces are desired or kung saan natin hinahanap by cutting the beam into two portions. Yung ginawa natin kanina, the method of sections nga. Number 3, select the portion that will require the least amount of computational effort. So, after natin i-cut yung beam natin, pipili tayo na kung alin ba doon na section or portion na mas kunti lang yung isasolve natin. So, mas maganda kung kukunti lang yung mga applied forces, tapos yung reactions, mga ganun. Number 4, determine the axial force at the section by algebraically summing the components in this direction parallel to the axis of the beam of all external loads and support reactions. So for example, horizontal yung structure natin. Para makuha natin guys yung axial force, we'll apply the summation of forces horizontal. And for number 5, determine the shear at the section by algebraically summing the components in the direction perpendicular to the axis of the beam of all external loads and support reactions acting on the selected portion. So, para masolve natin guys yung shear, for example ulit, yung structure natin na horizontal, dapat yung i-apply natin is the summation of forces vertical naman. And for number 6, determine the bending moment at the section by algebraically summing the moments about the section of all the external forces plus the moments of any external couples acting on the selected portion. So, parang magmo-moment lang tayo at that point kung saan tayo nag-cut or kung saan tayo nagkuha ng section in our structure. And yung last procedure, so syempre, i-check natin yung calculations. So the results on both left and right portions must be identical. So kung anong inakuha natin guys na internal forces para sa left portion, dapat equal din sa right portion. Dapat equal. So for example problem, determine the shear and bending moment at point B of the beam shown in the figure. So meron tayong cantilever beam which is fixed supported at A and free end at C. So yung hinahanap natin dito is sa location at point B. So ano ba dito yung shear and bending moment? So i-solve natin yan. Yung step number 1, we will compute the support reactions by applying the equations of equilibrium. So first step, siguro kunin muna natin guys yung AY. So para makuha yan, we'll use summation of force vertical equal to 0 or equate natin lahat ng pataas sa lahat ng pababa. So yung pataas natin, walang iba kundi yung reaction lang na AY, and yung pababa is the load which is 20 kN per meter times 10 meters or the area of the distributed load length. We have a value of AY na 200 kN. If this is positive, ibig sabihin tama yung assumption natin na pataas yung AY. And para na makuha guys yung AX, we'll use the summation of force horizontal equal to 0 or equate natin lahat ng forces na direction to the right sa lahat ng forces na direction to the left. Yung force na direction to the right is 0 equal sa direction to the left which is AX lang. So we have the value of AX na equal to 0. And para makuha guys yung moment at point A, we will use summation of moment about point A equal to MA or equate natin lahat ng clockwise moments sa lahat ng counterclockwise moments. So mag-create ng clockwise moment is yung the load only, so 20 kN per meter times 10 meters magiging concentrated load times moment arm about point A which is 5 meters. So kalahati nun ng area 5 meter. Kaya 20 times 10 times 5 equal to, sa kabila naman yung mag-create ng counterclockwise is yung 500 kN. And yung assumption natin for MA na counterclockwise siya. So, kaya MA plus 500. So, simplify natin. So 20 times 10 times 5, this is 1,000. So, pag dilipat natin sa kabila yung 500, magiging negative. Kaya 1,000 minus 500 is equal to 500 kN per meter. So, pag positive yung nakuha natin, ibig sabihin, tama yung assumption natin for direction of MA. So, ang direction niya is counterclockwise. So, second step, guys. So, pass a section perpendicular to the centroidal axis of the beam at the point where the internal forces are desired by cutting the beam into two portions. So, magkakat tayo at point B, tapos magkakaroon tayong dalawang portion. So, ito yung hiniwalay natin. So, meron tayong left portion and right portion. Yung step number 3 natin, select the portion that will require the least amount of computational effort. So, kung babalikan natin guys yung kanina, kung papansin nyo, yung mas konti lang yung effort sa pag-compute para masolve natin yung internal forces, dapat yung consider natin is the right portion. Since na-compute natin yung reactions, we will use pa din this left portion. Tapos, gamitin ulit natin yung right portion na dapat same lang yung lalabas. So, we can use both or kung magbo-board exam kayo guys, syempre, dito na guys agad sa right portion. Pero for this presentation, i-solve natin both portions. So, gagamitin natin yung left portion and right portion. So, unahin muna natin guys yung left portion. So, we'll use summation of force vertical equal to 0. Equate natin lahat ng pataas na forces sa lahat ng pababa. So, yung pataas natin is yung AY only which is 200 kN and yung pababa is yung V natin which is the shear and the load na 20 kN per meter multiplied by length niya which is 6 meters. And we have a value of AY nga na 200 kN tapos simplify natin. So 20 times 6 is 120. So lipat sa kabila magiging negative. So 200 minus 120. So 80 kN na lang. Pag positive na nakuha natin, ibig sabihin tama yung direction natin for B which is pababa. Next, we will use summation forces horizontal equal to 0. Equate natin lahat ng forces to the right sa lahat ng forces to the left. So yung lahat ng forces to the right is yung actual A na equal to 0 kasi yung AX natin is 0. So A equals 0. Then next, we will solve the moment. So we will use summation of moment about the section equal to M. Or equate natin lahat ng clockwise sa lahat ng counter moments. So mag-create ng clockwise moment about the section. So mag-create ng clockwise is yung AY only. So AY times 6 meters about point B. And yung mag-create naman ng counter is yung M and the load and the reaction about point A. Kaya equal to M plus 500 which is the reaction about point A and the load which is 20 times 6 times yung moment arm which is 3 meters. So simplify natin. We have a value of AY which is 200 kN times 6 equal to, simplify natin guys ito. So equal to M plus 500. 20 times 6 times 3 is 360 kN meter. So pwede nyo guys i-pause using video and pwede nyo i-compute using your calculators. So simplify ko ulit. So 200 times 6 is 1,200 equal to m. 500 plus 360 is 860. So lipat natin sa kabila. So 12 minus 860. So we have a value of m na 340 kN meter about at point B. So pag positive yun ang natin, tama yung direction natin for moment na counterclockwise siya. So yun, nakuha natin guys using isang portion lang. Pero for checking naman, try natin guys gamitin yung right portion na dapat same lang yung makukuha natin yung values. So dapat yung A natin is 0, yung shear natin is 80, tapos yung moment natin is 340 din. So we'll use this portion. Apply natin yung equations of equilibrium. Summation of force vertical equals 0. Lahat ng pataas, equate natin sa lahat ng pababa. So yung pataas natin, yung V lang, kasi this time pataas na yung shear natin kasi nga, di ba? Pag nilipat natin sa another portion, babaliktad yung direction nila. So yung shear natin is pataas, then yung pababa natin is the load. So yung load is the 20 kN per meter times yung length niya is 4 meters. So we have a value of shear na 80 kN din. So same lang kanina yung value. But this time, pataas yung shear natin kasi nasa right portion tayo. Next, summation of force horizontal equal to 0. Equate natin lahat ng forces na direction to the right sa lahat ng forces na direction to the left. So ganun pa din kasi walang forces na horizontal kaya A equal to 0. So para naman makuha yung M, i-apply natin yung summation of moment about the section 10 equal to M or equate natin lahat ng clockwise moment sa lahat ng counterclockwise moments. So mag-create ng clockwise moment about the section is yung M mismo and the load. So M plus 20 kN per meter times 4 meters times 2 meters para sa moment arm equal to yung mag-create ng counterclockwise moment about the section is yung 500 kN meter. So simplify natin. So M plus 20 times 4 times 2, this is 160 kN meter equal to 500. And 500 minus 160, ganun pa din. So 340 kN meter. But sabi ko nga, babago yung direction this time. So yung direction for moment, pag nasa right portion, magiging clockwise moment na. So yun. So kahit saan guys, so pwedeng pag nag-cut kayo along the length of the beam or any structure, pag kinisider natin yung right portion or left portion, dapat same yung makuha natin na internal forces or stress resultants, which is actual forces, shear, and moment. Pero take note, yung kinuha natin, specific point lang, specific location lang. So next pag-usapan natin guys is the shear and bending moment diagrams. So for the shear and moment diagrams, the shear and bending moment diagrams depict the variations of these quantities along the length of the member. So kanina yung solution natin para masolve yung internal forces, kumukuha tayo ng specific location. Pero using the shear and moment diagrams, makukuha natin at any location of along the beam or along the length of the member, makukuha natin yung values ng internal forces natin. So hindi na siya specific. So makukuha natin at any location along the length of the member. So ang tawag dito is the shear and moment diagram. So these diagrams can be constructed by using the method of sections then, proceeding from one end of the member to the other. So from left to right along the length of the member to determine the equations expressing the shear and bending moment in terms of the distance of the section from a fixed origin. And the values of shear and bending moments determined from these equations are then plotted as coordinates against the position with respect to a member and as abscissa to obtain the shear and bending moment diagram. So this time, gagawa tayo ng mga equations and yung equation natin in terms of x. So kukuha tayo ng value ng length kung saan tayo nag-cut and yung location na yun, kukuha tayo ng fixed reference na kung saan yung fixed origin natin. So ipapakita ko na lang. So para maintindihan natin yung shear and moment diagram, mag-solve tayo ng example problem. So draw the shear and bending moment diagrams for the beam shown in the figure. So for this problem, meron tayong simple beam lang. So meron tayong apat na segments. So AB, BC, CD, and DE. And every length of the segment is 10 feet. Overall, yung A to E na length of the beam is 40 feet. And meron tayong concentrated load about point B na 60 kips or 60 kilopounds. Counterclockwise moment about point C na 180 kip feet. And meron tayong distributed load din na 2 kips per feet na magsimula siya from point C hanggang point E. That is distributed load. So yung first step natin, syempre, i-draw natin yung free body diagram niya, tapos i-solve natin yung external reactions natin. So meron tayong AY, AX, and DY. So first, yung equation equilibrium, gamitin natin yung summation of moment about point A equal to 0. So, isolve natin yung dy. Or, equate natin lahat ng clockwise moment sa lahat ng counterclockwise. So, about point A, yung mag-create ng clockwise moment is yung 60 na concentrated load and the distributed load which is 2K per feet. So, sa left equation, meron tayong 60 kips times yung moment arm niya from point A is 10 feet plus yung uniform distributed load natin na 2K per feet times 20 feet kasi yung length ng C is 20 times yung moment arm niya about point A is 30 kasi yung kalahati ng uniform load is 10 plus itong 20. So, bali yung moment arm niya about point A is 30 feet. Equal to yung mag-create ng counterclockwise moment about point A is 180 feet and yung dy na force natin na mag-create ng counterclockwise niya. So, equal to 180 feet plus dy times moment arm niya about point A is 30 feet. So, simplify natin. So, 60 times 10, this is 600. 2 times 20 times 30, this is 12. Tapos, yung 180 natin, nilipatan sa kabila, equal to 30 dy. So, 600 plus 12 minus 180, that is 1,620. So, pwede nyo guys i-pause ulit yung video and compute nyo yung value. Check nyo kung tama using your calculators. So, equal to 30 dy. So, divide both sides by 30. So, 1,620 divide 30, that is 54. So, cancel yung feet, kaya may iwan is kips na lang. So, yung dy natin is 54 kips. Positive yung nakuha natin. And yung direction natin for dy is pataas. So, next, pwede natin guys masolve yung ay na. So, we'll use the summation of force vertical equal to 0 or equate natin lahat ng forces na pataas sa lahat ng pababa. So, yung pataas natin is yung ay and dy and sa kabila, yung pababa naman is yung 60 kips plus yung 2K per feet na uniform distributed load. 2 kips per feet times 20 para maging concentrated load. So, meron tayong value ng dy na 54 kips equal to 60K plus 2 times 20, that is 40K. So, simplify natin. So, 60 plus 40, that is 100 minus 54, that is 46 kips. And that is pataas din. Next, summation of forces horizontal equal to 0. So, obvious din na yung AX natin is 0 kasi nga, wala tayong applied forces na horizontal. So, yung AX natin is 0. Next step, after natin masolve guys yung mga reactions, pwede na tayo guys maggamit ng method of section. So, kung ilang guys yung segment natin, ganun din kadami yung section natin. So, dun tayo magkukuha ng mga equation. Every segment, meron tayong equation dapat for shear and moment. So, una, for AB muna tayo mag-cut. So, magkakaroon tayo ng section AA. And yung distance niya from fixed position, yung lagi dito guys, yung kinukuwang fixed position is yung pinaka-left na dulo. So, yung pinaka-dulo at the left end. Ganun. So, ito yung magiging fixed position natin about the section. So, meron tayong value ng distance niya ng section about point A which is equal to X. So, along this section, kukunin natin guys yung value ng shear and moment. So, ano ba yung equation niya? So, kunin natin guys itong section after natin i-cut. Yung kunin natin lagi is the left portion. So, this is the internal forces niya. So, meron tayong shear and axial and moment. And laging ganito yung direction niya pag yung kinuha natin is the left portion. So, yung shear natin pababa, yung axial force natin is to the right, and yung moment natin is counterclockwise. After nun, makuha natin yung portion, we'll use the equations of equilibrium na. Equate natin lahat ng pataas sa lahat ng pababa. Yung pataas natin is the AY or the 46 kips, and yung pababa natin is the shear only. Kaya AY equals to B, and meron tayong value ng AY na 46 kips, and this is downward. Yung shear natin na 46 kips, dadaan lang to along segment AB, and this is constant. And magsisimula yan from 0 kasi yung fixed position natin, this is yung parang origin natin, mag-i-start about point A. So, dito guys, magsisimula yung value ng X natin, and pa syempre, yung direction ng X, pag to the right direction, that is positive. For this equation, mag-i-start yung X natin from 0 to 10. Kasi nga, 0 to 10 kasi yung AB natin or segment AB, that is 10 feet. So, every segment guys, that is 10 feet. So, para naman makuha guys natin yung moment about section AA, so we'll use summation of moment about section AA, equate natin sa M or the moment. So, equate natin lahat ng clockwise moment sa lahat ng counterclockwise. So, mag-create ng clockwise moment about the section AA is yung AY na reaction only. So, meron tayong moment na mag-create about section AA equal to AY times yung moment arm niya which is X. Equal to yung mag-create ng counterclockwise is yung moment. And meron tayong value value ng AY which is 46. So magiging equation natin for M now is 46x and yung unit niya dapat naka-keep fit. So this is for segment AB din and yung magsisimula yung x natin from 0 to 10. Next, after natin guys i-cut yung segment AB, ay kakat naman natin this time yung next segment which is BC. Then kunin ulit natin yung equation for shear and moment. So i-cut ulit natin yung BC. So yung this time yung section natin, tawagin natin yung BB. So kunin natin guys yung section and laging left portion yung kinukuha ko. And this time, ito na yung mismo yung value ng x natin. So tapos na tayo from A to B. So yung kukunin natin na equation is from B to C. So apply ulit natin guys yung equations of equilibrium. Equate natin lahat ng pataas, lahat ng pababa. So yung pataas is 46. Pero this time, may pababa tayo na V and 60 kips. So 46 kips equal to 60 kips plus V kasi sila yung pababa na forces. So meron tayong value ng shear this time in negative 14 kips. And itong value na shear, mag-start lang to along segment BC. And this is constant. And mag-start siya from 10 feet to 20 feet. Next, kunin naman natin guys yung moment about section BB. So summation of moment about section BB. So equate na lang natin lahat ng clockwise, lahat ng counter about this section. So mag-create ng clockwise yung reaction AY and yung mag-create ng counter is yung 60 and M. So 46 times moment arm niya is X about section BB equal to yung mag-create ng counter about section BB is yung 60 kips na yung moment arm niya is X minus 10. Kasi nga yung moment arm niya is magsisimula lang sa location niya hanggang dito sa section. If this is 10 feet, ibig sabihin yung moment arm niya lang niya is X minus 10 plus yung moment natin, M. So simplify natin, pag dinidistribute natin guys yung 60 in this equation, 60 times X, tapos pag nilipat magiging negative. Tapos 60 times negative 10, that is 600 negative. Tapos pag nilipatan sa kabilang equation, magiging positive 600. So simplify ulit natin. So 46 minus 60, magiging negative 14x. Tapos yung equation natin for M now, for segment BC is 600 minus 14x. So this is for segment BC and yung dadaanan niya is from 10 feet ulit to 20 feet. So from here to here. Next, yung kukunin natin guys na section is CC naman. So tapos na tayo sa BC. This time, yung segment na ikakat natin is yung segment CD. So kunin natin guys yung section na yun. So laging left portion. And this is the portion na yun. So meron tayong this time na moment about point C and meron tayong distributed load yung itong nakat natin. So apply ulit natin in equations of equilibrium or equate natin lahat ng pataas lahat ng pababa. So yung pataas natin is the 46 kips only or the AY and yung pababa natin is yung 60 kips and the counting distributed load natin. So meron tayong pataas na AY and yung pababa natin is yung 60 kips and yung distributed load natin na 2 kips per feet na yung multiplier natin or yung length ng uniform load is X minus 20. So this is X and yung nalagpasan natin guys yung AB and BC that is 10 feet. Yung length na lang ng distributed load natin is X minus 20. Tapos yung meron tayong shear pa plus V. So meron tayong value ng AY which is 46. So ilipat natin ito sa kabila. So 46 minus 60 kasi magiging negative. And ito din magiging negative na 2 kips per feet times X minus 20. Tapos simplify. So 46 minus 60 that is negative 14 kips. Tapos i-distribute natin yung 2. So 2 times X times negative so magiging negative 2X. Tapos 2 times 20 same negative magiging positive 40 kips. So simplify ulit natin. 40 minus 14 magiging 26 kips minus 2x. And this is the equation for shear along segment CD. Or mag-start na yan from 20 feet to 30 feet. Kasi from C to D. Then next, isolve natin guys yung equation for moment along segment CD. So mag-summation tayo ng moment about section CC. Equate natin sa M. Or equate lang natin yung lahat ng clockwise moment sa lahat ng counterclockwise about section CC. So mag-create ng clockwise moment about section CC is yung reaction about point na AY and yun lang. And yung mag-create ng counter about section CC is yung 2 kip per feet na distributed load and yung 60 kips from section AA. Tapos yung M natin which is yung kinahanap nga. So sa left equation, we have AY times X kasi this is the moment arm of AY natin about section CC. And sa kabila naman equation, medyo mahaba kasi yung mag-create ng clockwise moment is yung 60 kips na yung moment arm niya about section CC is X minus 10 kasi yung AB niya, this is 10 feet. So yung moment arm niya is X minus 10 plus yung 180 feet kasi yung direction niya is counterclockwise. Tapos yung distributed distributed load natin na 2K per feet times yung length niya, which is x minus 20, times kalahati nun is the moment arm, which is x minus 20 over 2, plus yung m. So, simplify natin equation, meron tayong AY na 46 kips times x equal to, i-distribute natin yung 60 kips, so magiging 60 times x, tapos ito magiging negative 600. So, 60 times x minus 600 plus 180 kips feet. Tapos ito, cancel lang yung 2, mag-iiwan is x minus 20 squared plus m. So, simplify ulit natin, combine like terms. So, 46 minus 60, then magiging negative 14 kips x. Tapos, yung 600 plus 180, magiging negative 420 yan. Pag nilipat sa kabila, magiging positive 420. Minus x minus 20 squared equal to, yung sa kabila, iniwan natin yung m. Then, we can expand yung x minus 20 squared. So, negative 14k x plus 420 minus, yung nasa loob is in-expand natin, x squared minus 40x plus 400. So, i-distribute natin yung negative para ma-simplify natin yung equation. So, negative 14kx plus 420 minus x squared plus 40x minus 400 equal to m. So, combine like terms. So, 14x plus 40, that is 26x. Tapos 420 minus 400, that is 20 na lang. Minus x squared equal to m. So this is now the equation for segment CD, and mag-start siya from 20 feet to 30 feet. So from C to D nga. So next section, syempre magkaka tayo sa pinaka-last na segment, which is DE. So this is the length now for x. And kunin ulit natin yung segment. So ganun pa din yung this segment from the left end. And ganun pa din, magagamit tayo ng equation of equilibrium. So, summation of forces vertical ulit. And equate natin lahat ng pataas sa lahat ng pababa. So, this time, yung pataas, meron tayong dalawa, which is 46 kips and 54 kips. Or, that is AY and DY. And yung pababa natin, ganun pa rin yung 60 na concentrated load. And the distributed load na 2 kips per feet. So, 60K plus 2 kips per feet times yung length niya is x minus 20 pa din. Kasi this is x. And this length na AB and BC, tig 10 yan, kaya 20. So, yung length now ng distributed load is ganun pa din na x minus 20 plus yung pababa, siyempre consider natin yung shear force natin na V. So simplify natin, meron tayong AY and DY na 46 kips and 54 kips. Tapos yung 2 kips per feet natin i-distribute natin, so 2x minus 2 times 20, that is 40 kips plus V. So simplify natin, 46 plus 54, that is 100 minus 60 magiging 40 plus 40 ulit, kaya 80 yon. So 80 kips minus 2x equal to V. Pwede nyo guys i-pause yung video tapos i-check nyo ulit yung pagkakalculate ko na dapat yung shear natin equal to 80 kips minus 2x. And this is the shear equation for segment DE. And mag-start yan, syempre, kung from D to E tayo, from 30 feet to 40 feet. So, this is the origin, no? Balikan ko lang yung A natin, that is the origin. So, for moment naman about section DD, mag-summation of moment tayo section DD, equate natin sa M, or equate natin lahat ng clockwise sa lahat ng counter about section DD. For the left equation, meron tayong AY times moment arm niya na X at section DD. And yung DY natin, yung moment arm niya is X minus 30 kasi tatlong segment yung nilagpasan natin. So, itong distance na lang about point D hanggang sa dito sa section DD, yung length na lang niya is X minus 30. Equal to, yung mag-create ng counterclockwise is yung 60 kips ulit, tapos yung 180 and the 2 kips per feet. So, yung moment arm nila is 60 kips, yung moment arm niya is x minus 10, tapos yung distributed load, so x minus 20 pa din, kasi yung A to C is 20, so 2 kips per feet times x minus 20, times yung moment arm niya about section DD, x minus 20 over 2, plus yung M natin, na yung direction din niya is counterclockwise. So simplify natin, meron tayong AY na 46, and meron tayong DY na 54, tapos equal to, tinanggal ko na guys yung mga units, no? So equal to 180 plus, distribute natin guys yung 60 kips natin, kaya 60x minus 600, cancel ulit dito yung 2, kaya x minus 20 squared plus m. So simplify, i-distribute ulit yung 54, so 46 plus 54 minus, kasi 54 times 30, that is negative 1,620 equal to, so yung sa kabila, 180 minus 600, that is negative 420, tapos 60x, tapos ito, in-expand ko na guys, kaya x squared minus 40x plus 400 plus m. yan. So, pwede nyo ulit yung i-pause yung video tapos i-check nyo guys yung pag-calculate ko kung accurate ba. So, simplify natin. 46x plus 54x, that is 100x, minus 60x, that is 40x. Tapos, ilipat natin yung 40x, siyempre magiging positive yun, so, kaya magkakaroon tayo ng 80x. Tapos, yung constant natin, 1620 negative, ilipat natin yung 400 and 420. So, dito pa lang, so 400 minus 420, that is negative 20. Pag nilipatan sa kabila, magiging positive yun, kaya 1620 plus 20, kaya magkakaroon tayo ng 1600. And pag nilipat natin yung x squared, magiging negative. Equal to, yung maiiwan sa kabila is yung m na lang. So, pwede nyo guys i-pause yung video tapos check nyo yung pag-calculate ko. This is now the equation for the moment at section DD or for segment DE natin. And yung x natin, magsisimula yan from 30 feet to 40 feet. So yun, nakuha natin guys lahat ng equations natin for shear, moment natin along lahat ng segments natin. Ngayon, i-draw natin yung shear diagram muna. So for the shear diagram, for AB natin, yung shear natin is 46. And sabi ko kanina, this is constant. Ibig sabihin, if this is positive, yung sign convention natin this time, pag mag-draw tayo ng shear diagram, pag pataas tayo, that is positive. Tapos pagpababa yung direction natin for shear, that is negative. As you can see, for segment AB, nakuha natin is positive 46 kips. Kaya magkakaroon tayo ng shear na pataas na 46K. And this is constant along AB, kaya mag-draw lang tayo ng horizontal line along segment AB. Magsimula yun nga from 0 to 10. So that is constant. And for segment BC naman, meron tayong shear na negative 14 kips. And this is constant then from 10 to 20 feet. So magkakaroon tayo ng 14 kips na negative. So nasa baba yan from B. Kasi from 10 feet, dapat marin tayong shear na negative 14. So i-drag lang natin yung pababa na negative 14. This is constant along segment BC. So along segment BC, meron tayong negative 14 kips na shear. And for CD naman na segment, for shear naman, meron tayong shear equation for segment CD na 26 kips minus 2x. And yung x natin, mag-start yan from C to D or from 20 feet to 30 feet. So if we have x equals to 20 feet, pag in-substitute natin yan, so 26 minus 2 times 20, that is 26 minus 40, or yung shear natin is negative 14 kips. O tama pa din. Pag nasa x natin equals to 20 at point C, ganun pa din dapat yung makuha natin na shear na negative 14 nga. And if x is 30 feet, ano bang shear natin? So 26 minus 2 times 30, so 26 minus 60, so meron tayong shear na negative 34. Nakalocate yan at point D. So meron tayong shear doon na negative 34. So check nyo guys, yung equation natin linear. Kasi yung exponent ng x is 1 lang, kaya that is a line, and yung degree niya is 1 only. Kaya ganyan yan. Pero pag yung equation natin dito is naka-square yung exponent ng variable natin, yung ano natin dito, dapat naka-curve na, tapos naka-second degree siya. Pero kung syempre, yung equation natin linear, dapat linear din yung drawing natin. The next, for segment D naman, meron tayong shear equation na 80 kips minus 2x. Ay yung dadaanan niya na equation from 30 feet to 40 feet, or from D to E. If meron tayong x equals to 30 feet, ano bang shear natin? So meron tayong positive 20. Ibig sabihin, aangat tayo dapat at point D na dapat meron tayong shear dyan at 20 kips. So this is the 20 kips. And if x naman is 40, yung shear natin is 0. Kasi 80 minus 2 times 40, 0. Mag-0 talaga dapat yung ano natin, yung shear diagram or moment diagram natin. So ganun pa din, if this is linear, dapat linear din yung drawing natin dito. So yun, i-close natin yan. So ito na yung pinaka-final na shear diagram natin. So dapat guys, mag-0 yung pinakadulo natin, or dapat ma-close natin yan para ma-check natin kung tama yung pagka-solve natin ng reactions and yung mga value ng shear equations natin. So this is now the shear diagram of the problem. Ngayon, i-solve natin guys, or i-draw natin yung bending moment diagram. And for segment AB, meron tayong equation for moment na 46x. And mag-start yan from 0 to 10. So obviously, yung equation natin, this is linear kasi yung exponent ng x is 1. Ibig sabihin, if x equals to 0, syempre, yung moment natin about point A is 0 din. Tapos, if x is 10, ano bang value natin ng m? So, 46 times 10, that is 460. At point B, meron tayong moment, 460 feet. And this is linear. Kasi nga, yung equation natin, that is linear. So, next, for segment BC naman, this is the equation for moment. 600 minus 14x, and yung dadaanan niya is from 10 feet to 20 feet. Check natin guys, if x equals to 10, 600 minus 14 times 10, that is 140. So 600 minus 140, babalik pa din sa 460. Pero if x equals to 20, yung m natin natin is 600 minus 14 times 20, that is 280. So 600 minus 280, that is 320. Positive. So yung pag-equation natin is linear, dapat linear din yung drawing natin. For segment CD, this is the equation for M, and this time, this is a quadratic equation. Yung nadaanan niya is from 20 feet to 30 feet. If x equals to 20, anong value natin ng M natin? At x equals to 20, meron tayong value na 140 kips. So 20 feet, bababa siya ng 140. So from 320 magiging 140 lang. And saka tayo mag-start ng curve or second degree na curve pag naglagpas tayo sa 20 feet. So for example, 21 feet, 22 feet, hanggang umabot tayo ng 30 feet. Ganun guys, makukuha natin yung curve na line natin. Kasi yung equation natin, this is the second degree. So expect natin yung drawing natin dapat naka second degree din. So hindi na linear. If x now is 30, anong value natin ng m? So at x equals to 30, syempre yung location niya at point D, and nakuha natin is negative 100. So pwede nyo guys i-pause yung video, tapos i-substitute guys yung x na value dito sa equation, and dapat yung makuha natin na value is negative 100. So pag in-drawing natin yan, ganito yung drawing niya, and this is second degree. So mamaya ipaliwanag ko guys bakit ganyan yung curve niya, bakit pababa yung opening niya, and anong tawag sa kanya, anong tawag sa curve niya yan. And next, for segment D naman, yung equation natin for moment, this is 80x minus 1,600 minus x squared equals m, and mag-start yung x niya from 30 feet to 40 feet. So if x equals to 30, anong value ng m natin? So i-substitute natin yung 30 dito sa equation, and same pa din. So at point D, ganun pa din. And if x equals to 40, the value of m is 0. Kasi dapat talaga from end to end, dapat mag-0 yung value ng moment natin. Kasi pag hindi yan nag-close yung diagram natin, ibig sabihin mali yung pagkasolve nyo ng mga equation or even the reactions. Yung diagram natin dito from D to E, ito yung drawing. And that is second degree din. Kasi yung equation natin for M, for DE, naka second degree. So expect may curvature siya. Mamaya ipaliwanag ko kung bakit ganyan yung opening niya, bakit downward opening, bakit upward opening. So ganun. Ipapaliwanag ko yan sa second solution natin, which is graphical. So pag i-close na natin yan, ito na yung moment or bending moment diagram for this problem. Ngayon, yung solution natin, kanina, that is the algebraic method. Pero this time, isolve natin yung shear and moment diagram using graphical method. So hindi tayo magagamit ng mga equation. So titingnan lang natin yung drawing natin or the loads natin and reactions. So yung sign convention natin dito, pag pataas yung forces, pataas din, positive yung diagram natin. So for shear diagram, if we have 40 skips about point A, aangat ka lang ng 40 skips. Pwede nyo guys i-scale yan kung mag-solve kayo sa papel. Hindi yan naka-scale dito sa presentation natin. Assumption ko lang na ganyan yung length niya. Tapos, pag wala tayong load along segment AB, ibig sabihin magiging constant lang yung 40 skips natin along segment AB. Kaya mag-draw ako ng horizontal line. Then after dito, meron tayong load na 60 kips. So if we have 46 and meron tayong kababa na 60 kips, ibig sabihin this is negative. So 46 minus 60, magkakaroon tayo ng negative 14 kips. And ganun pa din, pag wala tayong load along segment BC, constant lang yung shear natin for BC natin. Kaya mag-draw ulit ako ng horizontal line along segment BC. And pagdating dito, yung load natin from C to D na, meron tayong distributed load. So this is 2 kips per feet. So ang gagawin natin para maging concentrated load yon, yung distributed load natin, i-minus lang natin dito. So this is downward, so that this is negative 10. So negative 2 times 10 para maging concentrated load. So from negative 14, magma-minus ulit tayo ng area ng load. Negative 14 minus 2 times 10 kasi downward yung distributed load natin. Negative 14 minus 20, that is negative 34. And may meron tayong pataas na concentrated load or for the reaction na 54 kips. So 54, this is positive. So 54 minus 34, magkakaroon tayo ng 20 kips. And from here naman, magma-minus ulit tayo ng load na 2 kips per feet times 10. So that is 20 minus 2 times 10. Kaya mag-0 ulit. So this is the shear diagram using graphical method. And for bending moment diagram naman, yung gagamitin natin yung area of this shear diagram. So yung titingnan natin para ma-solve yung bending moment diagram is the shear diagram. So para ma-compute yun, we will solve the area ng natin, ng shear diagram. So for segment AB, if this is rectangular, dapat magiging triangular yan pag nilipat natin sa bending moment. And isolve natin guys yung area. So for area for this rectangle, para sa segment AB, this is 10 feet. Ibig sabihin, magkakaroon tayo ng moment at point B na 46 times 10, that is 460 feet. And meron tayong area na negative para sa segment BC. Magma-minus tayo ng negative 14 times 10. So 460 minus negative 14 times 10, this area na nasa baba. So 460 minus 140, that is 320. Positive pa din. Kaya ganyan yan. Tandaan nyo guys, if this is 0 degree from shear diagram, yung susunod niyan para sa bending moment, magiging linear na yan or first degree. Kaya from here, from 0 degree, magiging first degree din to. Then next, as you can see, meron tayong load dito na 180 feet. So, ang mangyayari, pag yung direction natin, di ba pag sa external loads natin, pag yung direction is counterclockwise, that is negative. So, ibig sabihin, from 320, magma-minus tayo ng 180 feet kasi yung direction niya is negative nga kasi that is counterclockwise. So, 320 minus 180, that is 140 feet. So, bababa tayo ng 140. And saka tayo mag-minus ng area ng trapezoid para makuha natin yung value ng moment about dito sa broken lines natin about point D. So, complete natin yung area ng trapezoid. So, we have B1 plus B2 over 2 times height. So, yung B1 natin, let's say this negative 14. Yung B2 natin is negative 34 over 2 times yung length niya, that is 10 feet. So, negative 14 plus negative 34 over 2 times 10. Sa taas, that is negative 48 over 2 times 10. So, that is negative 240. And ito yung ima-minus natin sa 140. Kaya magkakaroon tayo ng 140 minus 240. We have negative 100 pa din. Yung tanong, bakit ganito yung opening niya? Bakit downward? And anong tawag dito guys? So, this curve, this is second degree, and this is parabola. So, para makuha natin guys yung parabola, kung saan guys yung vertex ng triangle, as you can see, pag kinat ito guys natin, this is the vertex of the triangle. Kung saan nakalocate yung vertex of the triangle, dun din nakalocate yung vertex of the parabola. Tapos, yung if the sloping of the triangle is negative, kasi obviously this is negative ba? If we have Cartesian coordinate plane, for example, itong plane na to, if this is the if this is the line or the slope of the line, that is positive. Pero pag baliktad, pag ganito yung pag ganito yung sloping niya, that is negative. Ibig sabihin, pag in-draw natin yung parabola, dapat opening downward siya. Kasi ito, yung sloping niya is negative. So, dapat pababa din yung opening ng parabola natin. And ulitin ko, kung nasan guys nakalocate yung vertex of the triangle, nandun din yung nakalocate yung vertex of the parabola. So, ito yung parabola opening downward. So, from 100, ngayon, if we have positive area, ipa-plus natin yung itong area. So, itong area, that is 1 half times 20 times 10. So, 1 half times 20 times 10, that is positive 100. Kaya, negative 100 plus 100, magsasara ulit to 0. And ang tanong, bakit ganito ulit yung curvature niya and opening downward? Sabi ko kanina, kung nasa nakalocate nyo guys yung vertex of the triangle, dun din nakalocate yung vertex of the parabola. And if this is sloping is negative, ibig sabihin, yung opening ng parabola, that is downward din. Kaya ganyan yung opening niya. And yan, yun na yun. Pag sinara natin, this is now the bending moment diagram. So we have two solutions in solving the shear diagram and bending moment diagram. Pwede nating algebraically gagawa tayo ng equation, or pwede tayong magrekta na, which is the graphical method na tinatawag. So that's it. Thank you very much guys for listening, and I hope natutunan kayo dito sa shear moment diagrams natin. And thank you very much. Have a good day.